The densely populated communities living within sight of Krakatoa, on the coastal areas of West Java and southern Sumatra, now had only hours before the full force of the volcano would devastate the area.
Once the volcano really started getting going at lunchtime on the 26th, things were going to go from bad to worse. There were big explosions every 10 minutes or so, and these merged together to form a column of ash and debris which extended up to something like 25 kilometers, 18 miles into the atmosphere. There was heavy ashfall, there was a lot of pumice falling on ships out in the straits. And by late afternoon, everywhere was pitch black, and you probably could hardly see a hand in front of your face. You would have had earthquakes going on, accompanying these explosions. At the same time, you would have been having these flows of hot debris called pyroclastic flows entering the sea, and the sea would have been getting increasingly agitated.
The ship closest to Krakatoa that afternoon, just 12 miles away, was the Governor-General Ludon.
Keep her away from the coast! We mustn't be drawn inland.
Hot, sticky volcanic ash fell from the dark clouds, smothering the ship.
Get that paraffin off the deck before it explodes! Overboard! All of this! Overboard! Overboard!
By the evening of the 26th of August, the loud explosions coming from Krakatoa were clearly heard 83 miles east in Batavia. The heavy rain of ash and pumice spread 23 miles north to Ketimbang in southern Sumatra.
We must leave. I'll get Yanni ready. Sumbi, we'll need food and water.
I can't leave.
We must leave.
It's out of the question for the controller to leave his post.
Do you hear that? God knows how much worse it will get.
We are not leaving. I have to see what's happening in the village.
By early morning the following day, grey ash had reached Batavia, casting a strange wintry hue on an otherwise tropical city. At 5:30 a.m., the first of 4 cataclysmic explosions occurred on Krakatoa. Pyroclastic flows of dense material cascaded down the flanks of the volcano, and immense submarine slides generated giant shock waves in the surrounding ocean. In the Sunda Strait, the shockwaves were witnessed as huge crests of water.
God. Turn her into the wave now! As fast as you can! Let yourself down!
When these first waves reached the coastline of Java, they slowed and reared up to enormous height, revealing the full horror of a tsunami. Today, all that's left of the Fourth Point Lighthouse are the remains of its foundations, a 6-foot-thick brick buttress. Despite its obvious strengths, the structure was unable to survive the enormous force of the tsunami.
The lighthouse seemed as if it was going to survive, but then it was hit by a block of coral estimated to weigh something like 600 tons, which had been scraped up from the seabed and which had crashed into the base of the lighthouse. And it looked as if it separated the lighthouse from its base, and the whole thing toppled over and was then broken up and carried off in the water.
2 years after the destruction of the Fourth Point Lighthouse, a new one was built just yards from the original.
The new Fourth Point Lighthouse, it's 40 meters high, which is just about the height of the largest wave. And looking down from here, it's almost unbelievable that you could get a wave that high. It would have completely trashed the whole region. I mean, a wave of 40 meters, and remember, this isn't just like a single wave that crashes onto a beach. Tsunami have very long wavelengths, so the waves can be hundreds of meters or several kilometers long, so they come in as a wall of water, and that wall just keeps coming, and it would have just wiped out everything entirely.
A total of 19,600 Javanese died on this stretch of coastline alone. These black and white photographs of the destruction, taken over 120 years ago, are sadly all too familiar today.
The 2004 tsunami was more destructive in the sense that it killed more people over a large area, and that is because such a big area of seabed was jolted upwards, and that sent these waves out. The waves generated by the Krakatoa eruption were much, much bigger, but they lost energy very rapidly, so they didn't travel any great distances.
The Fourth Point tsunami stripped the sand from the beaches and destroyed everything in its path. It seemed like the end of the world, but worse was yet to come. At 6:44 a.m. on the morning of the 27th of August, 1883, Krakatoa erupted again, literally ripping itself apart in an explosion equivalent to the power of 1,000 atomic bombs. Why this small volcanic island in the Indonesian archipelago exploded with such ferocity has puzzled volcanologists for almost 100 years. In order to answer that question, Mike Rampino is on his way to Krakatoa, to the only part of the volcano that remains today, the island of Krakatoa. Rampino first visited Krakatoa in 1979 to pick over the remains of the eruption in search of vital evidence. He's now returning with local guide Samsul to confirm his theory.
The first time I was here with a group of scientists, we were looking at the pyroclastic deposits, the pumice deposits of the 1883 eruption, specifically to try and figure out what the triggering mechanism was for the enormous explosion that took place in August of 1883.
The initial theory to explain the extreme violence of Krakatoa's eruptions was that seawater seeped inside the volcano and mixed with the magma to create the huge explosions. This theory did not stand up to scrutiny.
We were testing the idea that seawater got into the volcanic vent, and that's what caused the explosion. What we found was that usually those kinds of eruptions have very, very fine-grained pumices. The pumices are fragmented by the reaction with the water. And here at Krakatoa, I've seen that the pumices are rather large. And so the lack of fine-grained material suggests that it wasn't seawater getting into the vent that triggered the eruption.
If seawater didn't trigger these huge explosions, what did? Hidden in Krakatoa's dense jungle are thick layers of pumice ejected from the volcano in 1883. This volcanic rock is a permanent record of what happened deep beneath Krakatoa and why it erupted with such exceptional violence.
Here we could find huge charcoal and also pumice everywhere. Yeah, here. Yes, one. And then, oh, this is really big
Huge
pumice.
pumices.
Wow.
On the island, but in the charcoal here, trees that were killed by the ash.
Yeah.
So beautiful sequence of pumices, finer grain, another pumice layer, but small pumices, and then the pyroclastic flow deposits going all the way to the top of the outcrop.
Like this?
Yes, yes,
Oh my God.
yes. The whole eruption sequence, you can see it here.
Molten rock lying inside Krakatoa's magma chamber for 200 years of dormancy was light in color and cool in temperature. After the initial eruption in May, the magma chamber was part emptied, and that void was filled from below by dark-colored magma that was extremely hot in temperature. It was a lethal cocktail. As the two mixed together, the intense heat of the dark magma created huge amounts of gas that expanded, eventually creating enough pressure to cause the volcano to erupt with terrifying force.
So this is the mixed pumice. It's got the light material and the dark material. Two different kinds of magma that triggered the 1883 eruption. This light-colored magma was sitting there for a long time in the magma chamber, and then this dark-colored stuff came in from the bottom, heated it up, and caused it to overturn, and for the gas to begin to come out of the magma, and the pressure built up, and that's what caused the volcanic eruption, yes, yes.
This mixing of two magmas beneath Krakatoa was the direct cause of the massive explosions. And when combined with Krakatoa's unique position in the middle of the Sunda Strait, it could lead to only one outcome: complete and utter devastation. At 2 minutes past 10, on the morning of the 27th of August 1883, Krakatoa exploded once more, this time with such extreme intensity that it was heard over a twelfth of the Earth's surface. The sound of the detonation was carried 2,000 miles south to Perth, Australia, and 3,000 miles west to Rodriguez Island in the Indian Ocean. It remains the longest distance traveled by any airborne sound in recorded history.
This was the climax of the whole eruptive sequence, one of the loudest noises, if not the loudest noise ever heard by modern humans. And I think people by then must have begun to wonder, is this the end of the world? Is this just affecting us here, or is everybody experiencing this?
As Krakatoa tore itself apart, it generated another tsunami, this time directed north towards Ketimbang, only 23 miles away.
Anna!
Sumbi, give me Yanni. Open the cage. Let it go.
We have to get to higher ground.
Situated directly behind Ketimbang was Mount Rajabasa. By a stroke of incredible luck, the Bearings managed to reach higher ground and escape the clutches of the tsunami. They sheltered in a hut 400 feet above sea level on the slopes of Mount Rajabasa.
Nothing could survive this. We will all die here.
No, we will not die. Help will come from Batavia.
You think Batavia still exists?
By mid-morning on the 27th of August, 8,038 people had died around Ketimbang. Leaving death and destruction in its wake, the tsunami funneled up the Lampong Bay, continuing to slow in speed and gather in height.
Tsunami are all incredibly affected by topography, and they will get funneled by bays, by estuaries, by harbours, etc. And that happened here in Lampong Bay. The wave that devastated the entire low-lying region around the bay here. The fishing communities on Sumatra would have had no chance at all. The wave that came up this bay was 24 metres high, so you're talking maybe 80 or 90 feet high. This would have been a wall of water which just continued to come inland for several minutes. There would have been no chance to survive unless you were close to high ground and could actually make a run for it, because the waves would be travelling as fast as a sprinter could run, and most people wouldn't have a chance of outrunning that.
At the head of the Lampong Bay, lying directly in the path of the tsunami, was Telok Betong, the largest port in southern Sumatra. The entire town was washed away, killing a further 2,263 people.
This is the mouth of the river Koripan, which is at the head of Lampong Bay. And it's an excellent example of what Telok Betong would have looked like after the tsunami had funneled up the bay and then gone back out again. A scene of complete devastation, really. Mud covering everything, trees sheared off so that all you see are the stumps sticking up, and no sign at all of human habitation.
In the harbour at Telok Betong was the Dutch government steamship, the Baru. Its mooring buoy now lies as a forgotten monument to the dead. This is the only memorial for the Indonesian victims of Krakatoa. With similar power to the 2004 tsunami, the wave generated by Krakatoa picked up the steamship Baru and her crew of 28 and carried them inland. Their final resting place can be found almost 2 miles up the river Koripan.
The Baru was already suffering because the seas were getting very agitated, and then a big tsunami tore the ship from its mooring buoy and dumped it up this river here. This is where it all ended for the Baru and her 28 dead crewmen. 1.8 miles up the Koripan River, about 30 feet above sea level. When the boat was found, which was about a month after the eruption, it was actually in very good condition. It was stretched across the river here. It was full of ash and mud, but its engines were in working order, and if it could have been got back to the sea, it could have actually been seaworthy again. But its real fate was much more ignominious than that. It just sat here rusting away for many decades, virtually disappearing after 50 years or so. Its huge boiler remained behind until that was washed down in a flash flood in 1979 and finally cut up for scrap.
By late afternoon on the 27th of August, the eruption of Krakatoa had ceased. When the ash and smoke cleared, the volcano was gone.
Madam.
No! No, Yanni! Yanni!
One of the last casualties of Krakatoa was the Bering's child. Burnt, choked by ash and poisonous gas, the baby eventually succumbed to the trauma. Reports following the eruption reveal that Tamang, the lighthouse keeper, miraculously survived the tsunami. His wife and child, however, did not. Despite his personal tragedy, records show that Tamang stood by his post, performing his duty as keeper, warning passing ships in the Sunda Strait.
Apa nih, Ras?
Pemerintah sudah janji makanan. Kalian akan diperhatikan. Rumah kalian akan dibangun kembali.
Within hours of the final eruption, the dramatic news was being transmitted around the world. Reports of the mounting death toll and devastation dominated the headlines. In total, 36,417 people died, and 165 towns and villages were destroyed. It remains to this day the largest known death toll from any volcanic eruption.
most of those deaths resulted from water, from the oceans, from the tsunami, not from the direct effects of hot rock. And that's something that many people don't appreciate about volcanic eruptions, even today, that the big killers include tsunami and include things like volcanic mud flows. And in fact, a number of the great disasters, volcanic disasters, have been caused by these relatively indirect effects.
In the years that followed, Willem Berink remained the controller. He was determined to see his duty through, and he and his wife oversaw the rebuilding of Ketimbang.
Keep them. Build your own library.
I have something for you. A memento of our adventure. A piece of Krakatoa. What's left of it.
Thank you. Home. Home to Utrecht.
Orang kudu nyatu. Loba lauk di laut.
The names and obituaries of the 37 Europeans who died were published throughout the world. But for the tens of thousands of Indonesian victims, the tragedy was never officially recognized. But it wasn't just Indonesia that was changed by Krakatoa. For many years after 1883, the effects of the eruption would be felt right around the world. The explosion of Krakatoa in 1883 was the most devastating volcanic eruption in modern recorded history. In total, 36,417 people died. 11 cubic miles of rock had been blasted into the atmosphere. The The shell of Krakatoa collapsed beneath the surface of the water into the empty magma chamber. All that was left was the southern half of Rakata and the existing islands of Velaten and Lang.
If you add up all the material that was erupted by Krakatoa and brought it to Manhattan, you could cover the island of Manhattan to a depth of about 200 feet. That's the volume of material ejected during the massive phase of the Krakatoa eruption in 1883.
No atomic bomb blast can rival the sound that the final eruption made. The shock waves from the explosion reverberated around the globe 7 times and were still detectable 5 days later.
Very few people appreciate how cataclysmic volcanic eruptions can be. And in fact, 500 million people live within the danger zones around active volcanoes today. That's more than 1 in 12 of the Earth's population. But the thing is, volcanoes aren't always going to sit there looking pretty. Every now and again they generate these cataclysmic eruptions. That's something that Krakatoa taught us, and I think people only then began to realize, certainly scientists, that a single volcanic eruption could be so powerful as to affect everyone on the planet.
Krakatoa erupted in a Dutch colony, but it was left to British scientists to document and analyze its effect around the world. Dr. Eleanor Highwood is a meteorologist at Reading University. She's visiting the Royal Society in London. The Society was established in 1660 to promote the pursuit of natural knowledge. And in January 1884, it set up a Krakatoa committee to investigate the effects of the eruption on a global scale. Dr. Highwood studies changes in climate and atmospheric conditions after large volcanic eruptions. And the Royal Society contains the most comprehensive collection of material devoted to Krakatoa.
Are these for me?
Yes, they are. These are the papers relating to the Krakatoa Committee, and that's the committee minutes.
Okay. Thank you.
The Krakatoa Committee collated in meticulous detail documentation from all over the world. They collected newspaper cuttings and ship's logs, commissioned scientific reports, and even invited the public to write in with eyewitness accounts of the effects of Krakatoa. The result was the most comprehensive report of a volcanic eruption of its time.
So this report starts right from the start of the volcanic eruption, talking about the geology, and then it covers everything. It goes through the sea waves. There's time scales for the atmospheric waves passing around the globe 7 times, and they're recorded everywhere from Australia right the way through to Oxford. Really a global phenomenon. And then an awful lot on optical phenomena, so twilight effects, sunsets, sunrises. So August the 29th, from Japan, the sun was blood red with jets like smoke passing across its face. A month later or so, Hazelmere in Surrey, light pink cirrus stripes at sunset. Buenos Aires, the last days of September, the glows began. They lasted 1 hour 30 minutes. The sun and moon were occasionally coloured. And there's evidence here that this continued for 4 or 5 years. This was really the first evidence that started to give meteorologists a good idea of how matter is transported through the atmosphere.
These changes in the night sky, within days of the eruption, confirmed the existence of high-speed, high-altitude winds that transported volcanic particles through the atmosphere. Today, these winds are known as jet streams, and their discovery has played a pivotal role in our understanding of the weather. The eruption of Krakatoa propelled 11 cubic miles of ash and dust into the air. The heavier material fell back to Earth, but the tiniest particles and sulfur dioxide gas continued to rise into the upper atmosphere. Within days, carried by jet streams, this aerosol of tiny droplets of sulfuric acid veiled 70% of the world and reflected solar radiation back to space. The result was an overall cooling of the Earth's temperature by 0.5 degrees Celsius. But this process had another impact on the globe. It turned the skies blood red. Housed in the archive of London's Science Museum is perhaps the most vibrant example of how Krakatoa affected weather systems on the other side of the world. Curator Wendy Sheridan is showing Dr. Highwood the work of Victorian painter William Ascroft. Between September 1883 and 1886, Ascroft sketched the changing skies from Chelsea, West London. The result is a series of extraordinary oil pastels.
This is the first panel of 72 of 533 sketches that the artist William Ascroft started sketching in 1883 when he noticed changes in the colours of sunsets, and he spent 4 years in virtually the same place sketching them, timing each sketch according to the changes in the colours.
So this sequence shows some particularly vivid colours, some very, very strong red and yellow coloration through the whole of the atmosphere. So these really vivid reds are a product of the fact that there was aerosol in the stratosphere that had been transported from the Krakatoa eruption, and light passing through that layer is scattered, but it's scattered differently depending on what colour it is.
Really?
And so we tend to see reds more strongly in sunsets and sunrises.
In an age of black and white photography, Ascroft's unique work acts as a time-lapse account of how Krakatoa, thousands of miles away, directly affected the British skyline. Over 120 years later, the story of Krakatoa is far from over. Although the eruption in 1883 almost completely destroyed the entire volcano, from its ashes, a new one is emerging. In the middle of the old caldera lies Anak Krakatau, the child of Krakatoa, and it's active and growing. Mike Rampino set foot on Anak 26 years ago. He's now returning there with Dr. Rudy Hadisantino from the Volcanological Survey of Indonesia. Rudy accompanied him on his first trip.
This must grow so fast. This
very fast growth,
yeah.
Because there was almost no forest here when we were here last time. So the lava flows on the other side of the island. This side of the island mostly jungle, but so this is the end of the forest, and there is
like
twice as big as it was 25 years ago.
Yeah.
When I was here with you.
Yeah, right.
In its short life, the volcano has injured 5 tourists and claimed the life of 1, hit by a lava bomb exploding out of the crater. There's now an official warning advising against venturing onto the island.
It's hard to climb.
Yeah, very steep.
Anak Krakatoa first revealed itself in December 1927, when it erupted violently just beneath the surface of the water. Since then, it has been erupting with increasing intensity and growing rapidly at a rate of 15 feet every year. Today, Anak is over 2,600 feet high, almost the same height Krakatoa was in 1883. It covers 1¼ square miles, and between 1992 and 2000, ejected over 3,000 tons of material. It appears that Krakatoa is preparing itself for another huge eruption.
So almost at the main crater?
Yeah.
It's here. Oh.
Ah.
Wow.
Wow.
My
Big
goodness,
gas
look at the size
on
of
the
this.
crater. What do you think of the diameter?
It looks about 200 meters across, 600
Yeah.
feet across.
Yeah, I think so.
Yeah.
Yeah.
And the fumaroles
Yeah.
here. I'm choking though from the sulfur dioxide. We're standing here on an active volcano, Anak Krakatoa. The old peak of Krakatoa is behind us, and the old craters, the eruption centers for the 1883 eruption, were on the same line. So that's why volcanologists now think that there was a fault line, a fissure that ran along in a straight line here, along which all of these volcanic centers were erupting. The sulfur.
Anak Krakatoa is being carefully monitored by the Volcanological Survey of Indonesia, and particular attention is being paid to the viscosity of the magma.
Yeah. What's the temperature?
110.
110 Celsius.
110.
In the future, we would expect that Anak Krakatoa would build a larger and larger volcano here, but eventually things going on inside the Earth will cause changes in the type of magma that's coming up, and the more viscous it is, the more chance of congealed magma sealing or blocking the throat of the volcano, the more chance of an explosive eruption.
Anak Krakatoa will continue to grow in size, and it's a geological inevitability that sooner or later processes deep beneath the volcano will cause Krakatoa to erupt once more with paroxysmal force. As we know from the tragic events of the tsunami of 2004, history repeats itself. And for the people of Indonesia living in this geologically unstable region, the unpredictability of nature is all too real.
The tragedy of Krakatoa was it was located in the middle of the Sunda Straits, surrounded by water and surrounded by coastlines that were fairly densely populated, very low-lying coastlines, unprotected in any way from these kinds of waves.
The work of Sherman, van der Stock, and the Royal Society was an important step in advancing modern science's understanding of how these geological processes work. But the challenge for the future is not just to understand these forces, but to predict them. The hard lessons learned are that the destructive power of nature should never be underestimated. Krakatoa and the tsunami of 2004 remind us that we live on an active planet where the Earth's crust is constantly destroyed and regenerated. These immense geological forces going on beneath us reveal themselves in unforeseen ways and with terrible consequences.
Should the tsunami disaster make us think more about the way government spends our money? Jon Snow hosts a special live dispatches debate on Monday at 8. And you can learn more about the power of volcanoes at our special website, channel4.com/science.